The Evolution of Computer Software, a Complete History from Early Code to Modern Systems. Introduction to the History of Computer Software. Computer software did not appear suddenly. Instead, it evolved through decades of innovation and experimentation. Early scientists imagined programmable machines long before modern computers existed. However, practical software development began during the 20th century. At that time, computers were massive and extremely expensive. Moreover, programming them required deep technical knowledge and patience. Software gradually transformed how humans interact with machines. Consequently, computers moved from laboratories into businesses and homes. Today, software drives communication, education, entertainment, and global industry. The first era, machine code and early programming, 1940s. Early computers used pure machine code. Programmers wrote instructions using binary numbers consisting of zeros and ones. Therefore, programming required extreme precision and mathematical understanding. Engineers manually entered instructions through switches and punch cards. Meanwhile, each instruction controlled a tiny operation inside the computer. For example, commands moved data, performed calculations, or stored results. However, this process consumed enormous time and effort. Even simple tasks required long sequences of binary instructions. Consequently, programmers searched for easier ways to communicate with machines. Despite the difficulty, machine code formed the foundation of all software development. Every modern program still translates into machine instructions eventually. The rise of assembly language, 1950s. Assembly language emerged as the first major improvement in programming. Instead of binary numbers, programmers used short symbolic codes. For instance, commands such as add or load represented machine operations. As a result, programmers could read and write instructions more easily. Furthermore, translators called assemblers converted symbolic code into machine language. Assembly programming still required strong technical knowledge. Nevertheless, development became faster and less error-prone. Therefore, engineers could focus more on problem solving. During this period, computers began supporting scientific research and government operations. Consequently, the demand for better programming tools increased rapidly. The birth of high-level programming languages. High-level programming languages changed the software world dramatically. These languages allowed programmers to write instructions using words and mathematical expressions. One of the earliest examples appeared in the late 1950s. It focused on scientific and engineering calculations. Soon afterward, additional languages supported business data processing. High-level languages introduced compilers. Compilers translated human-readable code into machine instructions automatically. Therefore, programmers could develop complex programs faster. Moreover, programs became portable across different machines. Previously, software worked only on a specific computer model. However, compilers allowed code adaptation for new systems. Consequently, software development expanded quickly across universities and corporations. The onset of operating systems. As computers became more powerful, they needed better control systems. Operating systems solved this challenge. These systems managed hardware, memory, and program execution. Early computers ran one program at a time. However, operating systems allowed multiple tasks to run efficiently. Therefore, system resources improved significantly. Operating systems also simplified computer usage. Users no longer interacted directly with machine code. Instead, they used commands and software interfaces. During the 1960s and 1970s, operating systems became essential components of every computer. Furthermore, time-sharing systems allowed many users to access one computer simultaneously. This development expanded computing access for universities and research institutions. The personal computer revolution, 1970s to 1980s. The invention of personal computers changed software development forever. Computers moved from large organizations into individual homes and offices. Consequently, software companies began creating programs for everyday users. Word processors, spreadsheets, and games quickly gained popularity. Meanwhile, programming languages also evolved. Developers created languages designed for flexibility and readability. These languages allowed programmers to build larger applications efficiently. Graphical user interfaces appeared during this period as well. Instead of typing commands, users interacted through icons and windows. Therefore, computers became accessible to non-technical users. The personal computer revolution created an entirely new software industry. The Internet era and software expansion, 1990s. The growth of the Internet transformed software development dramatically. Computers connected across global networks. Consequently, developers created programs designed for online communication. Web browsers became essential tools for navigating digital information. Meanwhile, websites evolved from simple pages into complex applications. Programming languages adapted to support Internet technology. Developers built systems capable of handling global communication and massive data exchange. Additionally, open-source development gained popularity during this period. Programmers worldwide collaborated on shared software projects. Therefore, innovation accelerated rapidly. The Internet era expanded software influence across nearly every industry. Modern software development and cloud technology. Modern software development focuses on speed, scalability, and global accessibility. Now, developers build applications that run across multiple devices and platforms. Cloud computing plays a major role in this transformation. Instead of relying on local computers, applications run on remote servers. Consequently, users can access software anywhere with Internet connectivity. Mobile technology also reshaped software design. Smartphones and tablets require lightweight and efficient applications. Therefore, developers emphasize performance and user experience. Artificial intelligence and machine learning further expand software capabilities. These technologies enable computers to analyze data, recognize patterns, and support decision-making. As a result, software now influences healthcare, transportation, finance, and entertainment. The future of computer software. Software evolution continues at an incredible pace. Emerging technologies promise even greater innovation in the coming decades. Quantum computing may introduce entirely new programming methods. Meanwhile, artificial intelligence will automate many development tasks. Additionally, immersive technologies such as virtual reality will demand advanced software systems. Consequently, developers must design new tools and frameworks. Cybersecurity will remain a critical priority. As digital systems expand, protecting information becomes increasingly important. Ultimately, software will remain the foundation of modern technological progress. The history of computer software reflects constant innovation and adaptation. Early programmers struggled with complex machine code. However, new languages and tools gradually simplified development. Operating systems, personal computers, and the Internet accelerated software growth. Consequently, digital technology reshaped modern society. Today, software connects billions of people worldwide. Moreover, it powers industries, research, and everyday life. The journey from binary code to intelligent systems demonstrates remarkable human creativity. Therefore, the evolution of software continues to shape the future of technology.